Can you hear me now?
Yes, I can hear you.
At last. At last.
Talk about technology.
And that's the topic
These,
which we are talking of today. I mean, it's not what we would prefer to show to the world, but well, that's how it's been. Anyway, Professor Mukhopadhyay, we are so grateful that you are with us today, so late at night from your location in Indianapolis, and a professor of your stature and your in-depth knowledge of artificial intelligence, its applications, and different uses of artificial intelligence would be an asset, the knowledge which you impart today, and we are looking forward to your valuable input. Uh, we already have questions coming in, so I will hold off the questions uh, till the end of the program, meaning your presentation. After that, I will ask you the questions and would request you to see if you could help us or guide the people on who had asked these questions. And we hope that your inputs will help us to create a new India, which is the whole purpose of this program. So, over to you, Professor Snehashish Mukhopadhyay, and we look forward to your valuable inputs. Thank you, Professor Mukhopadhyay.
thank you. Thank you, Dr. Bhattacharya. It's my pleasure to stay up late at night to make this presentation. And of course, my name is Snehashish Mukhopadhyay. I'm a professor in Computer and Information Science, as well as the Associate Director of the STEM Education, Innovation and Research Institute here at IUPUI. And I'm originally from India, from Indian Institute of Science, Bangalore, but I did my PhD in this country, and since then I've worked at General Motors Research Lab, and then a faculty member at the current university. And so this is the Technology Development Conclave, and I will start that off my presentation off with a quote from Isaac Asimov, um, the famous science fiction writer, who said that any sufficiently advanced technology is indistinguishable from magic. That was his quote, and we see this magic happening in various sectors. We see that in information technology, we see that uh, in smart cars, we see that in smart power grids, we see that in smart healthcare, smart agriculture. So every sector is quote and unquote becoming smarter. And so obviously it's not possible for me in the limited time to talk about every single sector, but instead I'll focus on primarily on the information technology sector, talking about some of our recent research results and research approaches um, in the field of so-called interactive data science, and I'll define what I mean by that, and as well as its applications in some of the problems that are faced in the so-called smart cities, which is a very popular term that has been introduced in recent times all over the world. Um, and so, with that, let me share my screen. I have some PowerPoint slides. So
मेरा लैपटॉप दे दीजिए. Carry on, professor.
yes, just a minute. Let me
वो क्वेश्चन स्नेहाशीष वाले क्वेश्चंस दीजिए.
share screen.
How much?
See, I have used Zoom before, and so I know how to do it with Zoom. But this is
There is a button at the bottom which is share.
share, yeah. But I'm not seeing the PowerPoint window. Let me see. Can you see my PowerPoint slides now? No? Okay, it has come on. Just a minute. It just took a little bit of time. Just a minute. Okay. Share. Okay, can you see my screen? Interactive.
Yes, yes.
Okay, let me do the slideshow. So my topic of presentation today is interactive data science and its applications to smart city. And I'll start that off by another quote. This time it's from Jimmy Wells, who is the founder of Wikipedia, the famous online information repository where you can find information about everything. And so Jimmy Wells said the following: mathematical formulas alone do not produce consistently relevant results. Human intelligence is still a very important part of the process. So this idea about mathematics or slash computation, machines, as well as humans coexisting or working together to solve a complex problem, that is the domain of human computer systems, or human centered computing systems. And our work on interactive data science falls in that area. So because data science deals with extracting knowledge from large volumes of data using machine learning techniques. So let's just quickly review some of these terms, what they mean. So this is again Wikipedia's, the same Wikipedia's definition of the term knowledge and learning. So the knowledge is defined as learning or understanding gained through experience, whereas learning is defined as gaining knowledge through experience. So you see the circularity of the definition. Knowledge is defined in terms of learning, learning is defined in terms of knowledge. So this is a fundamental problem, because when we say knowledge, what exactly are we talking about? So that we need to keep in mind. And we'll try to be more specific about that during the presentation. And also to quote from Bauer and Hilgard, who wrote a book in 1981 on the theories of learning. And they said, if epistemology is the theory of knowledge, learning can aptly be called experimental epistemology. So in that sense, machine learning is like experimental biology or experimental chemistry, but only this time it is experimental epistemology. So through experiments, which results in the data, knowledge is discovered in a specific problem domain. So when we talk about learning, our interest is in human computer mutual learning. But learning can happen with the teachers, with a approach called supervised learning, where a teacher tells an agent, a machine, or another human being what is the right thing to do. Or learning can happen without a teacher. So that's unsupervised learning, where we have data, like a whole bunch of images that are collected from aircraft, but nobody has told us what the correct labels are. What do they mean? Which ones are trees, or which ones are houses, which ones are cars? So the agent has to learn by itself how to classify these large volumes of data. But our work focuses on so-called mutual learning, where it is where two agents are working together, and the two agents can be both humans, one machine, or two machines. When I say machine, I mean computer algorithms. And one agent treats the other agent as the teacher. So that way they can enhance or make more efficient their individual learning processes by using the knowledge that the other agent has accumulated. So we envision that mutual learning happen in future between two humans. So that is the domain of, let's say, two students in a classroom learning from each other. That's the domain of psychology. So psychologists worry about social psychology, to be more precise, about group dynamics with humans. Or it could be the learning can be between a human and a machine. That is the domain of human computer interaction. And there is a lot of work, research in that area, where human beings and computer algorithms are working in the loop, human in the loop system. They are working together, and one is learning from the other. Or the mutual learning can happen between two machines, two algorithms, two robots. So, but they are doing identical tasks. How do they learn from each other? Two cars. Can one car learn from the other car? So that is kind of the domain of mutual learning. Now, we're going to talk about interactive data science, and so there the human is uh, in the loop. Human is an essential part of the data science process. Typically, data science involves uh, offline processing of large volumes of data. There is no involvement typically of the user or the human. Now, if you can involve the human in the process of data science, in model building, in knowledge extraction, in decision making, then you can leverage the human's intuition of the problem also, along with the algorithmic analysis that the machine learning is doing. You can involve humans background knowledge or expertise or intuition about the problem to make learning faster, to make better decision, to make decisions that are accepted by human communities, because in many applications these data science decisions will have to be implemented by humans. And if they don't understand, if they don't agree with the decision, the participation will be very low. And so to involve and to have the human users take stewardship of the decision process. So it's like when you go to a bank, and the bank is for loans, housing loans or car loans. Well, there is an algorithmic process, but the algorithm assigns a loan risk to each applicant based on lot of applicant data, income, other debt, uh, 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 and assets and things like that. Um, but always the human beings is in charge. The loan manager, who is a person, ultimately makes the decision, and the algorithm just acts as an advisory system. So our objective is to involve such human participation in every stage of the data science pipeline. And by that I mean the transformation of data to information, and that is like selecting relevant data. Relevant data is information, and transforming information to model building using machine learning, and I'll talk about a little bit about that. Extracting knowledge or patterns of data from the information as well as from the models. That's the data mining aspect. And finally, based on the extracted knowledge, make intelligent decisions. That's the decision making process. So there is a whole series of transformation, and human users can be incorporated at every stage, as we have demonstrated in our research work. So, for example, data to information transformation, identifying relevant data, that is called information filtering. And we have proposed methods for interactive information filtering, where a user in feedback with the algorithm helps it to identify which data items are relevant in the given problem domain. Similarly, interactive machine learning. We have done work on interactive machine learning, where you are using a machine learning algorithm that periodically the user visualizes the model that is being generated and provides feedback about its errors, about missing data, about erroneous data, and things like that. And that way, learning happens much faster, as we have demonstrated. Or interactive pattern mining, where item sets, frequent item sets, are extracted from, again, large volumes of data. Like these items uh, co-occur or occur together in large frequency. So typically that process is non-interactive, and that's a computationally intensive process. I mean, literally millions of such item sets are identified, most of which are irrelevant to a given user. If I am a medical researcher and I am an expert in diabetes, why would I care about such extracted patterns dealing with a different disease? So the interactive pattern mining process quickly identifies what type of patterns or frequent item sets the user, a given user is interested in, and only extracts those. And again, we have demonstrated that through this process, it can extract relevant patterns much faster than a non-interactive process. And finally, decision making, we have demonstrated interactive optimization, where a user provides feedback about how well or how optimal the decisions generated by an algorithm is. And that feedback is incorporated to generate the next candidates. And so, as I said, it can be incorporated at every stage of the data science pipeline. Now, I won't go into the details of the method. I mean, mostly I'll talk about the concepts and the overview of some of our work. And for the details, you can refer to some of the papers that I'm referring to here, some of our papers. And I'll be happy to share those papers with any interested viewer in the audience.
Sir, a small interruption. I would request you to kindly send the papers by mail to us, because
Sure.
there are a lot of enthusiastic participants. Your questions are piling up and they really want to see the papers. And
Sure.
it would be an honor if you could share it with us so that we could share it with the participants who are
Right.
online right now.
All of these papers are available on Google Scholar. So talk about
Okay.
data science and large-scale repository. Google Scholars have all these papers, but I will extract the papers and I'll send them as attachment, as PDF files to anybody who is interested. So I'll do that over the next couple of days or so. But
Thank you very much, sir.
Sure. This is our work on information filtering. So I won't again go into the details of this is an agent. This is a software that is collecting documents or information and presenting it to the user by indicating which ones are relevant to the users, which ones are not. So that is the overall problem. And again, there is a representation, classification, profile learning or profile management, along with other adaptation modules. Let's not get into the details, but I would like you to focus on the last circle at the end, which is the user. It's an essential part. The user is an essential part of the agent. So the agent is in feedback with the user. Agent is a software, user is a human being, and they are working in feedback with each other. So this work was published a while ago, and this is kind of a typical result with actual human users. So the solid line indicates the degree of relevance of the documents with information filtering, and the dotted line indicates the degree of relevance without information filtering. With the information filtering process, you are achieve much higher degree of relevance. It's normalized to between 0 and 1, and they're using some mathematical formula. So the system is identifying relevant information, whether it's email, whether it is some research articles. It is determining which ones are of relevance to a given user at a much higher success rate than without any information filtering. And this is our framework for interactive machine learning. So typically, a machine learning process goes from top to the bottom. Some training samples are provided, a machine learning algorithm is used on those training samples, a model is built, and that's where it ends. Now we are saying that the model is visualized by a user. Again, the user is in feedback, and the user identifies new samples. And so it's an iterative process. It's not one shot process. And the machine learning again updates the model based on the new samples. And this process goes on until the performance is deemed satisfactory. And with that, we have demonstrated that the learning, machine learning, can happen a lot faster. Again, the orange line is without any interaction, non-interactive, whereas the blue line is the error rate with interactive machine learning. So as you can see, it's performing a lot better with the human interaction. Then let's talk about interactive pattern mining. So here the objective is to find item sets, like let's say jokingly they use the item set beer and diaper. Okay, you have a large transactional database from a supermarket store, and they say one frequent item set is beer and diaper. I don't know why that is the case. Why should customers that buy beer also like to buy diaper? I mean, but that has been found. This is like an empirical knowledge extracted from data. So similarly, which genes are related to which diseases, or which diseases are related to which medications? So these are kind of item sets that we are interested in. And typically, it's a non-interactive process. The algorithms like the a priori algorithm, the the random walk algorithms, and all these algorithms, they systematically, exhaustively generate every single item sets, frequent item sets that it finds in data, but most of which are irrelevant to the user. And so, can the user provide feedback about what kinds of patterns are of interest to them, and thereby the system will be able to focus only on those relevant patterns. And again, this is some experimental studies that we do. Sampler's precision. This is kind of the degree of relevance. So what percentage of the extracted patterns are relevant? With a non-interactive uniform distribution in a random walk algorithm, the precision is very poor. It is generating frequent patterns, no doubt, but those frequent patterns are of no interest to the user. Whereas the interactive algorithm, you can see, achieves much higher degree of precision. So it is not only extracting frequent patterns, but it is extracting relevant frequent patterns. So again, this is an illustration in the neuroscience domain, pictorial. This is a set of terms in the neuroscience domain. And I'm sorry, it's very crowded, but I just wanted to show the picture. So all these ovals or ellipses are terminologies that neuroscientists use, or which are actually either gene names or some chemical names or regions in the brain and so on. And typically, there is a large number of such terminologies, but the interactive process quickly identifies and eliminates many of the terms as irrelevant, but quickly identifies a set of terms which are of relevance and then finds associations amongst those terms. So this process results in much faster extractions of information. Then lastly, I'll talk about how to incorporate this user interaction in the decision making process. By that we mean an optimization algorithm such as a genetic algorithm. So we have done that work in recent times, and this is a reference to that paper. So typically a non-interactive approach goes like this. There is an algorithm which generates candidates like genetic algorithm, and then those candidates are numerically evaluated by means of some criteria like profit, like environmental impact, and so on. And then the algorithm goes back and modifies the candidates. So that's the non-interactive process. In the interactive process, we put a human in the loop. So after the numerical evaluation in terms of objective criteria, there is a human providing subjective evaluation. Those are also taken into account by the optimization algorithm to generate the next candidate. So this interaction or iterative loop between the algorithm and the user continues until a satisfactory solution is found or determined. And again, I won't go into the details of this picture. It's a little bit complicated, but I just wanted to show this to you to show that through the interactive process, community consensus is achieved much higher than the non-interactive process. And that is very important in many social problems. It is not good enough to generate a good solution, but you have to generate a solution that is acceptable to the human community. And the interactive process achieves that much faster. So let me not dwell on that point a little bit. So I will now go over to the second part of my talk, where I discuss some of the applications of this interactive data science to problems in smart city. And the smart city could be smart New Delhi, smart Kolkata, smart Mumbai, smart Chennai, so smart Bangalore. I think Bangalore is already quite smart. And again, I won't go into every single sector because a city is a very complex social construct. It has many dimensions. But I'll give you some illustrations about specific sectors, about how this kind of interactive data science technique can help with problems encountered in smart city. So I'll start off with some discussions about smart policing. And this is not my work, but this is the work of a junior colleague of mine, George Moeller, and he is very well known in the area of smart policing. And what that means is the following. So in a geographical region, be it a city or just a part of the city, there are crimes happening, and you want to somehow assign police officers in an intelligent way. You want to predict which areas the next crime is going to happen, and then assign or dispatch police officers to prevent that. So you are taking preventive action before even the crime happens. You are anticipating something to happen and taking steps to prevent that. So again, this picture shows a dynamic evolution of actual crime data. So here my colleague has collaborations with the Indianapolis Police Department, and they are using actual policing data, and these are the crimes that are dynamically happening in the Indianapolis city. And so the objective is to match the right people to place, time, and social harm risk for targeted intervention. So this is not just relevant to policing, but it can be for emergency medical services, where ambulances are assigned or dispatched to locations which are likely to see a lot of need or calls for such services. So this is what a human analyst does, and this is what an algorithm does to predict the crime. So on the left-hand side is the actual crime data. So the dark red spots are the hotspots, and we want to predict the hotspots where crime is happening. And a human analyst, typically a police officer, an experienced police officer, will predict some hotspots, and based on that, the dispatch will happen. Whereas the algorithmic predictions, as you can see, are very close in predicting the actual crime, the red spots in the algorithm data, particularly in the second one. In the second row, the red spot is the actual, on the left side, is the actual hotspot. And the red spots are what the human analysis in the middle, the human analysis is saying. And on the right hand side, you have the algorithmic prediction. Now, these predictions are by means of a statistical algorithm called point processes, where past data is used to predict future data. And this can be used in many applications. Point processes are very, very well known, but that is used to make decisions in this case. Now, of course, there are fairness considerations in using policing, because the diagram illustrates the problem, potential problem of such smart policing approach. So, of course, there is a police database which is used by the predictive algorithm to make prediction, which results in police activity, which in turn results in suspects and victims being identified, and that goes in the police database. In that process, the algorithm or the system may be biased against certain communities. Like in the United States, you have a problem that the criminal justice system is viewed as biased against African Americans, and this is the feedback loop that can lead to such problems. And that is a well-known problem in data science. I mean, the machine learning is as good as the data that it is provided with, and the data may be biased in itself.
Slides move me, correct.
Then let's talk about the next application area, which is smart transportation. And this is courtesy of the US Department of Transportation. And
sir, small interruption, please. My apologies. Sir, are you showing the slides one by one?
Yes.
But we are not able to see the slides moving. We just have the first opening slide. After that, we have not seen any of the slides moving on. Can you please check it at your end?
Let me see. Let me escape the thing. Can you see?
Yeah, now we can
smart
policing and emergency. Yes, now we can see that.
Okay, so there is some problem with the slideshow. So anyway,
okay,
so this is what
we can see the next slide.
Yeah, so this is the feedback loop. Now it's share the slides also.
Now it's moving.
Yeah, I'll share the slides also.
Yes, fairness consideration of algorithms in criminal justice.
Right.
Yeah, so, it's moving now.
Let me continue the presentation, and I'll share the slides for everybody. So
please.
I cannot go back and cover everything again, but
no, it's all right. It's all right, sir. Please carry on. Okay. Please carry on.
So, this is courtesy of US Department of Transportation, how this kind of data science or AI techniques can be incorporated in the transportation system. So the motivation is to reduce cost and loss of human lives. So typically, motor vehicle crashes are costly, and they're increasing in number. In 2014, in the United States, more than 32,000 people died, and the annual cost was estimated to be close to $1 trillion, and a leading cause of death for 4 to 34-year olds. It's one of the leading causes. I mean, so people talk about COVID-19. Of course, COVID-19 is a pandemic, and there is loss of life. But let's not forget other leading causes such as the regular flu or
Very true.
accidents or mental health or heart problems. I mean, so in the same manner, accidents is a leading cause of death, particularly in congested cities and so on. And US is falling behind other European countries and
अरे
Japan
महाकौशल एक्सप्रेस
in
बोलने
terms
से
of
दिखा
dealing with this kind of accidents.
हाँ वो वीर को
So
पता है
avoiding the crash. So that is one of the motivation of smart transportation. And the idea is to, if it is not possible to bring it down to zero, but at least make it so small, particularly with these transportation truck platoons of transportation trucks on the highways, uh, 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 driven autonomously by itself, and thereby reducing accidents and loss of human lives. So there are several technologies that come to bear on the smart transportation. There are connected vehicles, communication technology, and uh, uh, all the Bluetooth and other types of communications, making the vehicles connected, talking to each other, not only telling each other their positions, their next actions, and so on. Vehicle automations. All the cars these days have all kinds of bells and whistles. And so that is leading to a lot of automated decision making. Internet of Things, sensing various things, like sensing a slippery road due to rain or snow or something. So there is technology for that. Of course, machine learning, which is learning from the data to make intelligent decisions, that is part of that. And the data is large scale big data. And so the eventual need or motivation comes from mobility on demand rather than mobility as necessary. And so the benefits of such smart transportation are the following: orders of magnitude safety improvements, reduced congestion, reduced emissions, and use of fossil fuels. I mean, that was one of the main projects I worked on when I was at General Motors. How can you use intelligence control technologies to reduce fuel consumption and as well as emissions, improved access to jobs and services, reduced transportation costs for government and users, and improved accessibility and mobility. So some example systems are like adaptive cruise control. So of course, many cars have cruise controls, but it is controlled by a human operator. Because when you come close to another car, you reduce the speed. And but with sensors, cameras, and other types of sensors, you can sense the distance, and you can use that to adaptively change the cruise control. And yes, there is that technology is there today as we speak. And lane keeping assistance, keeping in your assigned lane, adaptive cruise control and lane keeping assistance, such as in traffic jam, where people get tired of waiting in a traffic jam, and that's where errors begin to happen. And automated parking, highway autopilot, as I said, platoon of delivery trucks. That's a problem that we have a center here at IUPY on intelligent highway transportation and highway systems, and they are addressing the problem of how to maintain a stable platoon, which is a which many trucks together in the presence of external disturbances and so on. So and then closed campus driverless shuttle. So if you are operating in a low risk environment, such as in a university and so on, uh, 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 and they have shuttles to take the students from one place to another. Can that be made driverless, automated? Valet parking in garage. So when you park in the garage, typically a human valet will come and take your car, park them. Can that be fully automated? Automated taxi. So these are some of the applications of automation in transportation systems. So there are human factors. Because there are humans involved, there are automated systems involved. Now, you cannot always demand that all cars be automated. There will be cars on the road which are driven by humans, and there are cars which are automated. How do they interact? Again, human machine interaction systems. And testing and certification complexity. Who certifies these automated vehicles? Of course, drivers take the test. But an automated vehicle, it is close to impossible to exhaustively test it. What happens if there is an accident? Who is at fault? And who has the liability? If it is taken to court, is it the software company? Is it the human owner? Who is to blame for that? And operate in changing environments. And of course, there are security problems, particularly when the vehicles are connected and they're talking to each other. Let me give some examples of smart health. I mean, there are research programs by National Institute of Health here, and as well as National Science Foundation, dealing with applications of AI in health technology. So this is some work that we have done. So these are the things that make smart city so-called smart, and that is an educated population. So when a patient comes in, a child comes in, a baby comes in, can you predict what is the likelihood of that child to become obese later on in life? And we demonstrated that using data from a clinical decision support system, an accurate machine learning model can be built to predict obesity in children after age 2. We also identified what are the leading causes, purely driven by data collected at the decision support system called Chica, which is actually in use here in the hospital. So that work was published in the Clinical Informatics Journal. Now, Cleveland Clinic is a very well-known hospital here in the city of Cleveland, and they use AI to make the patient experience much more efficient. So, kind of personalize the healthcare plans of the patient. You trained using past patient data. And then Zebra Medical Vision, which is a company in Israel, they use AI for radiology. So analyzing X-ray and other types of radiology images requires a high level of sophistication, is an expensive process. So typically, many hospitals in the US and Europe send those pictures to other countries. They outsource that. And they in turn do the labeling and return the result. Now that is less expensive probably, but that is also very expensive. But can it be done by AI? And so again, this is not a final call that the AI is making, but it is just making some recommendation. Which radio X-ray images are pointing to a disease and which are normal. And then finally, BioCell Therapeutics, which is a company in New Haven, Connecticut here, which uses AI to identify new medicines and potential new uses of existing medications. Okay. So this is just again to give you a flavor of how AI and data science can be used in smart health. Then the last area I want to mention is smart education. And again, here we collect a lot of data. So with the COVID-19 and everything, with a lot of online education, a huge volume of data is being collected by the so-called learning management systems. I mean, all the universities use some kind of electronic data system. Can you analyze that data that is being collected to make the educational experience better? So typical data may be student clicks, the amount of time that the students are using on each of the modules or each of the files that are being shared. And so one objective could be to predict students' affective state from such data, such as frustrated, confused, bored, engaged, and so on. So, if you can predict the student's mental state from the actions of the students, then you can use that to personalize the educational experience and even design the the educational methodology based on the student's predicted state. So, and then personalized information delivery. Some students uh, are, are better aligned with different types of information delivery modes. Some students react better to text data, some students react better to visual data, and again, there is a lot of scope for student clustering. Again, based on the learning management system data set. And so, for example, student, I mean, a possible type of knowledge that can be extracted is whether, for example, visual information is more effective for women than text. I mean, we don't know whether that is true or not, but that is the kind of knowledge that we hope to extract from the student data. There is a lot of work related to data science for education, and here is a well-known review paper where they talk about three types of student data: micro, meso, and macro. Micro are kind of the student activities like clicks and the time that the student is spending. Meso is like the student responses, like the student answers, student essays, discussions, and so on. And macro is the institutional, a large scale system data. And of course, when you use data science, there are concerns about privacy and bias, because if there are minorities that you're trying to address, but the data is not well represented in terms of these minorities, then your decisions could be biased also. And how do you prevent that? There is a lot of work on so-called fairness in AI, where you want to make the AI decisions fair to every single community, whether their minorities are represented or not. So, can interactive machine learning help to reduce inequity and bias in a student's educational experience? That's what I'm trying to do in the STEM Education Research Institute. And here are two recent popular articles. One is by Educause on artificial intelligence in education, and the other is by UNESCO, the United Nations Education Organization. And in 2019, they wrote a report on artificial intelligence in education. And you can see these are all publicly available. You can see them. So I'll end my talk with what I started off initially. Why do we need interactive data science? Because mathematical formulas or slash algorithms alone are not good enough. They are heavily influenced by data. They can be biased. They can give incorrect decisions. They may take a long time to extract the knowledge and make decisions, but you can make the whole process more accurate and lot faster by utilizing human intelligence also. So it is not one or the other, not just algorithms, not just humans, but they are working together. And that is the process which is very important part of the data science, the whole data science pipeline, as we discussed. So with that, I think I'll stop and I'll take any questions, comments. And
Thank you, Dr. Mukhopadhyay. It's been such a wonderful pleasure hearing from you so many different facets where artificial intelligence is being used and utilized. But before I come to the questions which have already come into my mobile here, because I'm also online on the mobile, I would like to ask a question from my side, if you permit me, sir.
sure.
Sir, we have a system in India today that is from, say, 2016 onwards, where if there is a requirement of a certain product by a manufacturer in the government sector, he floats a tender. Now, to quote in the tender quotation, the supplier has to comply with certain criteria which the tenderer mentions. And even to quote, he has to go to a particular electronic site, which is a government common website, and through the e-signature mode, he has to quote. Then the quotation is evaluated for in two parts: the technical part and the commercial part. The technical part is evaluated again using algorithms and data, which is from both sides, and then the people who qualify in that system and then moved on to the commercial part, wherein again the system defines who is the lowest priced amongst all these people who have qualified the technical aspect, and that lowest priced person or the organization gets the LOI, which means what I'm trying to say is there is practically non-existent human interaction in this entire process. Now, you have been talking about how humans need to be part of the algorithmic data converting into information, and algorithmic data getting converted into useful information, and for that you need the human intervention. Now, this is one facet, and there is the other facet wherein an organization asks for hard copies of quotation, hard copies of invoices, and hard copies of every document to support it, scrutinizes it physically with all the time he wants to take, and then finally the entire process, which probably the system could have done maybe in, say, 4 to 5 days. Both are of the same government organization or government, both government machinery. So while one takes only about 4 to 5 days to decide who is the best person suitable for the work, the other case it stretches on to months and years. And with the second part, there are umpteen number of cases or umpteen number of institutions where their projects are delayed by 8 years, 10 years, 12 years, purely because somebody somewhere did not evaluate it on time or evaluate it in the proper way or whatever. So
Right.
where do you think your subject fits in into the current scenario of the industry? I'm talking specifically of the government industry. I'm not talking of the private sector. That's a different ballgame.
Mhm.
And if I get into that, the debate will or discussion may get too long stretch. So I just have one question from my side,
Mhm.
and probably from my colleagues' side over here on the dais here, if you
Right.
could enlighten us on that.
Okay. So the point is that humans are slower, of course, slower than machines and algorithms. But humans possess something that machines don't. That is general background knowledge. This horrible thing that we possess, but algorithms do not possess. I mean, we know a lot of other factors that come into play in a tender allocation process or problem that the machine doesn't know. A machine only knows the data, whatever data is provided. So if there is a new situation which is not adequately captured by the past data, I mean, so in your case, you collect historical data and you train a machine learning about whom to allocate, whom to select. Uh, but if a new situation arises that is not represented in the data, the algorithm will make I mean random decisions in those cases. I mean, and that may be extremely poor, extremely unacceptable, unethical, or unfair in real world. Now, the human comes in those situations and says, well, we don't have data, but from my general knowledge of the problem domain, I know that this is the correct label or correct decision in this case. So the human and the algorithm can mutually reinforce each other. So while the human is using the algorithm as an advisory system, the algorithm is using the human to cover up incompleteness of its data or its knowledge. So I think a scope for interactive data science definitely exists in your problem area. Mhm.
Sir, just one last line from my side is whatever may be the past experience, the human part I'm talking, whatever may be the past experience or past expertise or present knowledge, if these are inputs fed into these algorithms, would they not be able to extrapolate and predict what would happen if XYZ alternatives happen in that particular scenarios?
I mean, extrapolations could be dangerous. I mean, as Yogi Berra says, it is extremely difficult to predict, particularly the future. Okay, so when it comes to a new situation, I mean, it will generate a decision based on the data, but that decision may not be the optimal decision in that case because we do not
Okay,
know what the correct decision is. The algorithm doesn't know. But
right.
in those cases, human intuition or human knowledge can be used to augment the algorithm's knowledge and the decision. So I think on every application area there are potential new situation, new data that that is not represented in the collected data, or in the collected data it may be an erroneous
Okay,
data. It may have the incorrect label, and
right.
so the human being can be used to correct those data to augment that. So supposing I'm building a machine learning model and the human user sees that the model is incorrect, because all machine learning algorithms has errors, right? I mean, you cannot give 100% accuracy. So in certain for certain data sets the algorithm is generating incorrect decisions, then the human is able to identify. The algorithm by itself doesn't know But the human can identify you are wrong in those cases. Go back and retrain yourself with the correct data to rectify your decision. So the model building process can be done in interaction with a human user. Hmm?
Okay, we have a question from Professor Kunal. What are the real challenges of learning happening between a machine and a human?
Language, translation. So we have identified four things. One is um, uh, goal congruence. Okay, so these are the necessary conditions. Are the human and the algorithm working towards the same goal? So we saw, if you have seen the movie 2001 Space Odyssey, the computer, the HAL computer, and the human Dave, the human, they ran into serious problems because they had goal incongruence. Whereas the human is trying to save human lives, to the computer, the success of the mission, the space mission, was more important than the human life. So that's the goal congruence. Translation, are they talking the same language? So, of course, in human to human also, we have that problem. If we communicate in languages that the
Yes.
other person cannot use. The third thing is trust. Do we have trust in the other agent? And that trust modeling, there is a lot of work in modeling trust in AI systems, but that is over past interaction, that is developed over time. And the fourth thing is discussion. Can we engage in a discussion where the human being asks the algorithm the explanation of the decisions? What is the process? I mean, what is the logic behind the decision that is made? And similarly, the algorithm can ask so there may be a dialogue before they learn from each other. And so these four are identified as necessary conditions for human computer interactions. Mhm.
Okay, there is a question from Sumit Prakash, IIT Delhi. Sumit wanted to know that our concept of smart city and your concept of smart city in the US are different. How likely do you think the concepts which you have discussed right now could be used, or which aspect of your smart city could be addressed on priority in the Indian context of the smart cities that we have today?
Smart transportation. I think it is coming. I mean, you may be thinking it's a strange thing that will never come, but pretty soon all these trucking companies and other will realize that the cost with smart transportation is much lower, and the technology will become less and less expensive, and it will be kind of a routine thing in vehicles. Smart healthcare. India's healthcare system is pretty advanced. I mean, particularly in top hospitals and so on. And in fact, a lot of people from US and Europe go to India for treatment because of health tourism. I mean, they provide equivalent, if not better, healthcare at a much lower cost. Also, smart healthcare is there already. I mean, when you go into a hospital, there are many systems that use algorithms and are to help in the decision making. Smart education. Education is pure, particularly when it is going to online and other setting where people see the disconnect between the student and the teacher because
Yes,
of the
yes,
virtual environment. The
absolutely.
AI can act as an intermediary. So I think these are there in some form and will be more visible in years to come.
Sir, let me ask you the question which Dr. Sunanda Snigdha Mukherjee, okay, Sunanda Snigdha Mukherjee from Calcutta has asked is that I find my students highly disenchanted and disinterested in the virtual classes which I take. What could I possibly do to improve the attentiveness and absorption of the students? Because I find even their performance are getting reflected in a negative manner when they are sitting for the examinations, which is incidentally as of now physical in the classrooms.
Right, right. So that's what I mean. A lot of education researchers are worried about. I mean, there is a visible impact on particularly lower income students, even in this country and other countries, um, um, uh, of disengagement with the education process. I mean, because of the lack of physical interaction, physical contact,
Absolutely.
the student. So, supposing you have a fairly intelligent, smart, I won't call it teaching assistant, but an avatar of an instructor interacting with the students. I mean, I'm not saying that the need for
You
physical
mean
interaction will
you mean
go
a
away.
robotic teacher? Are you intuiting that or suggesting a robotic teacher for taking classes?
A robotic teacher that takes on the persona of the human teacher.
Okay, so we are talking of a virtual teacher having the features of the real life teacher.
Right. So a virtual teacher or teaching assistant or somebody. I mean, there are a lot of work on intelligent tutoring systems. I mean,
Okay,
so in the spirit of that, a virtual entity interacting with the student when the human teacher cannot. So it is the second best thing, but it is definitely better than nothing at all. So
right.
this improve the learning thing. The other thing is to make the learning personalized. So if a student is more interested in certain types of information, be it visual, be it text, or be it some kind, or are interested in a particular sequence of topics, can we identify that and customize or personalize the education process to a student's need, preferences, habits, and so on? So, the adaptation of the instructional process to individual students. So, that is another. Mhm.
Okay, one last question, sir, from Sanjay Saxena, NHPC. He says that in most of the organization, people have moved on from preventive maintenance to proactive maintenance of the equipments. Now, during the process of his undergoing training for proactive maintenance, he found that all the data that was being collected was from the suppliers of the components, whereas the suppliers of the components were not giving correct data, meaning they were giving data based on a fact that they wanted, say, a lesser life of the component so that
Right.
they would be able to replenish the quantity. And
Bias data.
uh,
Mhm.
yes, and the
Yeah.
reality would have been probably much longer than what the suppliers were giving as inputs to the data. Now, how do an organization
Mhm.
handle the bias in terms of the predictiveness of a particular system or a component or a process?
You have to involve humans. I mean, the algorithm will never be able to detect that. I mean, if the data itself is biased, the algorithm's decisions will be biased. There is no two way about that. That's why you need the interactive feedback, where the
Okay,
human user or manager or somebody who knows,
whoever.
the
Yes,
expert,
Yes.
looks at the model and saying, well, this is generating biased decisions in for these types of data, and it rectifies the model by providing it with additional training data based on past experience. So I think in those kinds of situations, interactive data science is essential. Mhm.
Okay. Thank you very much, Professor Mukherjee. I think it must be way late night at your place in India, in Annapolis. And
And to
my
capitalize,
apologies
I
because
have a meeting tomorrow at 8 a.m. So I cannot
my
speak.
God, I'm so sorry. I'm so sorry we
No,
stressed your
it's a pleasure.
and
It's a
sir, my heartfelt gratitude towards you and for the excellent contribution to the smart city concepts of India. And for your kind information, sir, we'll be submitting the complete recorded data and report to the government of India, Department of Public Enterprise, and they will be taking up cues, pointers, and inputs from such faculties like you, and using it to try and create a new India, which we are all hoping for.
I
And
hope
thank you very much, sir. Just
so.
one more small thing I would like to mention, sir. Between 3 o'clock and 4 o'clock, three meaning 1500 hours and 1600 hours Indian Standard Time tomorrow, there would be a small ceremony in which you would be recognized by the dignitaries on the platform. So, just in case you are able to, if you could come online. Obviously, I cannot physically hand it over through the digital system. It's not yet possible right now, but probably somebody would receive the award on your behalf, and obviously, we assure you, sir, we will send it across to you to your location, and if you could come online, you could see it for yourself. That you will be felicitated probably by the either by the Vice Chancellor of Confederation of Indian University, or by Dr. C.P. Thakur, Cabinet Minister, ex-cabinet minister, and one of the most world-renowned doctors, the person who had invented, can't say invented, who had discovered smallpox vaccination for the entire world. Okay,
Great.
so
It would be an honor to be recognized by such.
so either of them would be
Yeah.
recognizing you. Of course, both of them would be available, and we would definitely look forward to having more sub interactive sessions from you, sir. Thank you very much. It was a
Well,
pleasure
it
having
was
you.
a pleasure on my part. Thank you.
Thank you.
Bye bye.
Bye bye. इनका कर दिया नहीं आशीष अब कुंदन लाल आएगा फोन मारो कैसे करते तुम उनको तो काट दिया मैंने काफी अच्छा आदमी को बोलना पड़ेगा अभी welcome, Professor Kundan Lal. It's a pleasure to have you with us. Probably
Yeah, well,
all miscommunications from our side, and we were not able to sort of coordinate the start in a proper way. But anyway, welcome to the program, sir. But before you start, let me introduce you to the participants and to the people who are online now and people who are live now. Professor Kundanalal is the president and mentor for VT Technologies. VT Technologies is an organization which has been working purely in the domain of artificial intelligence, its applications, its uses in the education sector, in the health sector, in the other sectors of the governments, and in the private sectors for quite some time now. Apart from that, Mr. Kundalalal has more than 36 years, more than 30 years of experience with various organizations, and all of them are one of the some of the topmost organizations in the past, and he's been actively handling a lot of clientele who are in this domain of artificial intelligence. So there could be possibly no one better than Professor Kundanalal, because he has seen the facet of artificial intelligence both from the perspective of uh, teacher and from the perspective of the industry. And we look forward to have you on this program, sir. And we are really grateful to be having you on this program. And we would look forward to you sharing with us your valuable insights on the way forward for application of modern technologies in the industry, and with specifics to the government industry, which is facing today a huge crisis. So over to you, Dr. Kundan, Professor Kundanlal, uh, and
So,
uh, it's a pleasure, a warm welcome to you once again.
so, Dr. Sev, are you able to see my slides? Thanks a lot for the introduction. Are you able to see my slides?
Not right now. It was
Now?
just a moment. Just a moment. Yes, 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 yes,
Okay, wonderful. So I'm going on the full mode now. I hope it is okay.
yes, yes. It's perfectly all right.
So thanks for the introduction, Sev. Let me give a brief before I start. I come from IT industry. I was the vice president of Capgemini earlier, looking after continental Europe deliveries. And before I moved into and established two organizations. One is Ativiti AI Technologies, which is a private limited company. We do a lot of commercial projects and a lot of skill development initiative, reskilling and retooling of professionals there. But along with that, I also had an organization known as Viti Research Foundation. It is already an 80G organization, and our focus is very clearly on AI-based applications and products which have got a lot of societal impact and public benefit involved. So that is what we are doing there, along with obviously the skill initiative or skill development initiative, which we undertake on AI, emerging and foundational technologies. Okay, so there are a lot of other technologies or subset of technologies which is actually augmenting AI technologies to come in. Okay, and which has enabled AI to be walking in. So that's a brief introduction about myself to all of your viewers, and let's go through the slides. Are you able to hear me, Dr. Sev?
Yes, you are very clear, and we are able to hear you. We are able to see the slide. Kindly try moving the slide, because in the past presentation you might have seen that we could not see the moving slides. Just can you move one slide down or one slide up, so that we are sure that the slides move? Yes, perfect, perfect. Please carry on. Please carry on.
Thank you. Thank you. So AI, I mean, I have heard of Professor Sinas's earlier also. And what I will be doing, I'll be taking a wider perspective of AI. Okay. And that's the focus which I wanted to bring in. quickly into my presentation. So if you look down below, this is the Homo sapiens. This is we are. This is we human, the Homo sapiens. And we have virtually taken over the world. We are not only taken over the world, probably we are destroying our world more with our technology at this point of time. But there is a guy coming up very fast in the back end, and that is being referred as artificial superintelligence. Okay, so this guy is coming up, and that is where a lot of worry factors are being there. And what they are pointing out, and some of the thinkers, they are pointing out, when ASI, or artificial superintelligence, becomes available, we will be on the left-hand side of the screen. And that is more go extinct, probably. That is what being referred. And I look at some of the statements, like Elon Musk, he says we are summoning the demon. हम राक्षस बुला रहे हैं, और जब राक्षस आता है तो क्या करता है? खा जाता है हमें. Okay, Stephen Hawking, he's not no more there, but he pointed out that artificial intelligence could spell the end of human race. That is what he said, one of the very sane astrophysicists. And look at the statement from Nick Bostrom, and you can download his book, and actually you can buy his book from Amazon now, and the superintelligence. And he said to Disneyland, a lot of collaterals, a lot of technology, but the children's will be not there. A Disneyland without children. That is what he's pointing out. Bharat went one step, his book, that's a wonderful book, Our Final Invention, and he says the artificial intelligence at the end of human era. Okay, but what I believe in more is the last statement of Werner. The physical extinction of human race is one possibility, but this is, and recently, if you are aware of it, Bill Gates came out and said, why can't we understand it? क्यों नहीं बात हमें समझ में आ रही है? So this is how the AI word is being denoted at this point of time. So let's look at the other aspect of it. AI is all around us. The way we travel, the way we do business, the way we socialize, the way we do politics, the way we shop. Everything is now being AI is there and putting his inputs. We at this point of time we call it an artificial narrow intelligence, or the word of machine learning. Okay, the algorithms. But this is how the AI will progress and come to us. So let me give you an example. When I say the AI is all around us, the way we shop. If you look at Amazon, the Amazon transportation burden at this point of time is around $2.37 billion. So when you order, and I believe every one of you must have ordered from Amazon at this point of time. So when you order on Amazon and place your order and pay for it, after that, one of the delivery executive will come and drop the thing at your place, right? That is the transportation burden of Amazon. So the model which currently Amazon is having, we call it shop and ship. So you shop it and they ship it to your home, right? Now they are leveraging AI. So Amazon is well known, the AWS cloud, the Amazon cloud, and they are very well into cognitive services, and they are well known for leveraging it. And they are experimenting that can be reduced, okay, by predicting the behavior and the buying patterns of people around us. And you are aware or not, every one of our profile is there with us. If you are buying, they know exactly what you buy, when you buy, what quality of product you buy, what is the requirement, what are you searching, okay? So they can predict, they can leverage AI to predict, and that is what they are experimenting. They are trying to change the model from shop and ship to ship and shop. So they will ship the things out to you. So the next day, next time you wake up, you will open the door and you will find there is the Amazon box in front of you, and you will open it up, and you will be amazed. Oh my God! Everything which I require today, that is available in this box, and you can take out the things, maybe a mobile device or a laptop or a belt, whatever, and you will take it out, leave the rest into the box. The executive will come and take it away, and you will be billed for what you have taken out. Okay, that is another way they want to bring down the burden on the transportation. They have already started experimenting, gentlemen. The way we do politics, if you look at that example, that very obvious example was, and it is being referred to the Facebook AI. So when the Trump took up the last time when he became the president of America, it is being touted that he won only by 110,000 votes, right? and that too in Pennsylvania, Michigan, and Wisconsin. And the thing is that Facebook sent, it is all being contributed to Facebook. The Facebook sent a message out just before the election day that your friends are going to vote, and your friends' photographs were there, thumbnails were there, and that resulted into an additional number of people who were probably Trump supporters to go on vote for it. It changed the entire politics and the election result also. And let me give you an example. The way we travel, the way we do business, this is also changing. Okay, so when you plan to travel, the travel packages and all, Google knows about that. That what you are searching for. And even if you are talking to Alexa, Alexa knows, Amazon knows about it, and you will start getting a lot of travel packages coming around you. Okay, there is all these algorithms are changing the world around us. It is making it more foresighted, more predictable, and they are bringing it on our table. Dr. Seb, I believe I am still being heard.
Absolutely, I'm very much there. I would like disturbing you between your presentation. There are already in, and we will be working on that after your presentations are over. And definitely, not only I am there, there are almost about 300 odd people online right now who are really hearing you, and I'm trying to understand what you are trying to explain to them along with me. For me also, it's a wonderful learning experience I'm going through, and for many of the other participants.
Thank you. So if you look at the trends, the Gartner hype cycle, Doctor, thank you. And look at the Gartner hype cycle, and you will see that a lot of AI technologies are actually going up on the platform of productivity, like speech recognition and GPU accelerators. And even if in the trough of disillusionment, the technologies which are there, like NLP and all, they're all AI-based technologies which are actually in the trough of disillusionment. That means that industry is now in a process of adopting it, though it is not meeting the expectations, but they are in process of adopting it more and more. The revenues from AI is being touted to reach $25 trillion by 2025 odd, right? So there is a huge number of job expectations, a huge number of jobs can be generated into AI and emerging and foundational technology space, and that is where we need to ensure that resources or our people, okay, being professionals and students, they cope up with this technology and they are more motivated to adopt this technology, start learning it, start adopting these technologies pretty good and pretty fast. Specifically, the academic institutions, they need to start working into this space more aggressively. Spend much more time. There are other people who will be defining it much more better. But currently, if you look at AI, there are two aspects which we need to understand it. There are the AI technologies where humans are still in the loop. We are making the decision. So like healthcare and all, we are being augmented. The doctors are being augmented. We are working with IIIT Bhagalpur, and they have come out with an X-ray analysis leveraging an algorithm for predicting COVID-19 or any other diseases, lung diseases actually. But what it and they have got the accuracy level is pretty high. I mean, it crosses 90% to certain extent, and certain to 76.3% odd. So pretty good accuracy it is giving it, and that is where the doctors can be augmented and identify the diseases from there. And it is also available on mobile devices. So these kind of technologies in healthcare and all is coming in pretty fast, leveraging AI. And if you look at where humans are looped, there are two categories. One is the assisted intelligence, which are basically hardwired specific systems, and they have been trained and they can do certain tasks, but they are not learning in the process. And then there are adaptive systems, which are augmented intelligence, which not only what has been trained for, they are doing it, but they are also learning into the process. Okay, so they are augmenting, they are evolving. These are adaptive systems. Now, AI is already there in the other part of where we are not in the loop, the automation, but they are in the industrial automation we are talking about. That is basically written by the human beings. If you go to the factory, a Volkswagen factory, probably it is completely automated, and the human interventions are pretty few into that. and the software is doing, or the robotic arms are doing the basic task of putting the doors into the car, or painting it, or putting the glass on top of it, or the interiors, and then the final car is out. Human interventions has become pretty less using this industrial automation. But down below, in adaptive systems, where we humans are not in loop, we call it autonomous intelligence. And that is where the autonomous, the technologies like autonomous vehicles are coming in. If you look at the Boston Dynamics, they have got the robotic systems, and they are walking better than us, actually carrying a larger weight, walking better than us, taking a backflip, which we humans are not capable of doing it. Probably few gymnasts, but generically we are not capable of taking a backflip. These robotic implementations are already doing it. You can go and hit the Boston Dynamics on YouTube and watch these robots walking and doing tasks, which is probably not, they're all leveraging AI technologies, okay? Autonomous vehicles, the prediction is by 2030, we humans will be not allowed to drive. It will be all these autonomous vehicle connected devices which will be ferrying people from one place to another. They have already reached level 3, and probably they will be reaching level 5 pretty soon. Okay, so this is the generic. I just wanted to introduce AI before I proceed forward. So if you look at from that perspective, the world we are living in is the world we call it artificial narrow intelligence. The world we are now going towards, and Microsoft has given up $1 billion to organizations like OpenAI, a foundation like with the Research Foundation, to develop artificial general intelligence technologies. If you want to try to understand that, a narrow intelligence or machine learning world which we are living in currently, these are algorithms. When you teach something else, they learn something good. If you teach something else, they forget it. Okay, and they operate on a structured data set. But AGI, when we reach AGI, we will be working as us, as human beings. It will be equal to us. Okay, it will work on our structured data set. So we humans, we operate on the taciturn, we operate on the olfactory organ, we smell it, we hear it, we taste it, and we see it, right? These are the 5 sensory organs we operate. That's the unstructured data set we operate upon. AI will start operating upon this. Second, if we learn cycling or swimming early childhood, we don't forget it. Any point of time in our life we are thrown in water, we'll be able to swim, or given a bicycle, we are able to drive it too, right? That is because we retain the memory, what we have learned. And that is where AI is trying to reach now. Okay, and that is when it reaches, they'll become an AGI, a general intelligence. From general intelligence to super intelligence, the differential is that all collective human intelligence put together, okay, all our books, all our knowledge set put together, that will be ASI. And the transition from AGI to ASI, that's the worry factor. Okay, so a lot of work going on, that's the worry factor. And that is where the worry to the human beings can exist. Okay, so a lot of other technologies that are being developed around it. There is the ethical questions like a good or responsible AI, can it be developed? Okay, so all the good AI and bad AI questions start coming in when you reach AGI and ASI level much more. But at the ANI level, already the autonomous lethal weapons has already become a point of worry. There is a committee on United Nations also formed up on that. India is party to it on autonomous lethal weapons as well, and the ethical questions of AI. So that is going to become more pronounced as the time passes by, as AI technologies become more prominent into our life. So applied AI is already, guys, there. The narrow intelligence, it is already on the slope of enlightenment, going up on the plateau of productivity. Industry is adopting AI more and more, or the machine learning world more and more. But there are triggers for the AGI which we should be cognizant of. Okay. So AI, if you look at, they are already doing a lot of job. It is driving the car, it is being a PIM, it is like personal assistant, it is playing a role of a translator, a machine operator, a soldier, a writer, a stockbroker, a chef. There are restaurants where you can go in and order food, and AI is actually cooking food for you. Okay, so it is playing, and if you understand the gaming industry, the Go, AlphaGo of Google, it has already defeated the world champion. And the AlphaZero and the world champion when defeated, but AlphaZero, what they have developed, it actually created AlphaGo, and now the probability of human being winning a game of Go from AlphaZero is 0%. They are becoming so good at it. Okay, and it has already learned 3,000 years of knowledge of Go, and humans cannot defeat it, and it is making moves, which is amazing, people. And there can be a security implementation of these kind of applications when Balloon is up. These kind of Alpha Zero kind of technology can be leveraged by countries for the next generation warfare, right? So we need to understand that, and because these the same strategies can be also utilized for a warfare as well. So this is something which worries world, which people are looking at. And if you look at the current the level of development, unsupervised learning is already there. The federated learning is there, and this federated learning tells you that your data will be not a problem. Your device will have the data, but AI will sit on it, learn it, and then be moved on the centralized AI to transmit the data set or the learning from your data. So your data will be still private, but the learning out of will be consolidated. That will be a collaborative machine learning without centralized training data set. It is already happening, or federated learning. It is already happening. One shot learning, it's pretty quick. It learns from the data sets which is there, like contextual, and any way you write from 0 to 9, it will know exactly what it means. Okay, and that he can learn in few seconds only. One shot learning. So this is where the AI today's paradigm is, gentlemen. Okay, it is moving in very fast. GPT-3, if you look at, they say it has been trained on 147 billion parameters. I was looking at China; they have already developed equal to GPT-3, they are calling it, and they have also trained it in a similar fashion with GPT-3. It can actually, what is being predicted, that if you throw a word at GPT-3, it can write the entire book for you. That kind of predictiveness it is bringing in, because he knows exactly what you are trying to say. So let's try to understand from the perspective of AGI triggers. I'll focus on one technology specifically. There are a lot of other technologies happening at an innovation trigger perspective, like brain-computer interface. So you'll be not typing, you'll be not doing affective computing, like your gesture and voice. So all this is happening, but along with that, there is one technology which is coming in very fast, that is quantum computing. And let's try to understand how it is going to change our world much more. Okay, so before I go there, let me tell you one aspect which is down below. I put it in. The Industrial Revolution 1.0, when gentlemen happened, it happened due to steam. Okay, and India, from Indian perspective, India was not party to it, and resultant was the railway engines were developed, machines were developed, steam ships were developed, and we were slaves of 200 years because we were not party to Industrial Revolution 1.0. To the Industrial Revolution 2.0, which was based on electricity, it created the great divide, the developed nations and underdeveloped nations. We are just coming out from being an underdeveloped nation from Indian perspective. Industrial Revolution 3.0, it happened due to computing. That is where we started catching up. So today we are doing a $287 billion IT exports. 55% of the world IT services we are supporting it here. 3.5 million people in India are working into AI industry or IT industry. IT industry. That is where we are catching up with the globe, right? In US, I see Indians are being called as smarties. We earn better. We save also better, and we are being called smarties. Okay. So that is where I feel that we started catching up with the world. But the Industrial Revolution 4.0, which is happening now, which is based on intelligence, if we are not party to it, probably we'll be looking at a permanent slavery in 10 years. So we need to be cognizant of this fact. Let us go to the quantum computing, specifically how it is going to impact AI world. See, if you look at from the human perspective, we do around our brain, we do around 26 quadrillion computations per second at a speed of 120 meters per second. And look at a supercomputer like Hunan 1 in China, it does around 32 quadrillion computations per second at speed of light, right? But the comparison ends here. The comparison, the way it ends here, we do 26 quadrillion computations per second in this cranial. ये खोपड़ी के अंदर करते हैं हम, right? At a very slow speed of 120 meters per second, no doubt. But we are doing it here. Hunan 1, for doing 32 quadrillion computations per second, it takes 724 square meter of space. Okay, we consume, the second aspect, we consume only 20 watts. But Hunan 1, a supercomputer, for doing 32 quadrillion computations per second, consumes 24 megawatts. So the comparison ends here. Okay. So if you what I'm trying to point out, that downloading a human brain or creating a human brain with the current technology set is probably not possible at this point of time. But very soon, if we look at from the quantum computing perspective, a 500 qubit of quantum computer will be equal to the total computational capability on this earth. All our mobile devices, servers, laptops put together, a 500 qubits of quantum computer will be more powerful. A 100 qubit quantum computer is more powerful than any supercomputer on this earth. Okay, and you know that Google has already announced the quantum computer supremacy, and they had a 72 qubits computer in 2018. But 2019, Reggie actually came out with 128 qubit computer, quantum computer, which is more powerful. And if you look from that perspective, from quantum encryption, hardware, software, building quantum computers to optical, all the areas, we are not party to it. India is not party to it currently. Okay. So our focus on the quantum computer needs to become more acute, because when it comes in, the supercomputer, which we know run one, will jump up by 100 million times. Okay, 10 crore guna. वो powerful हो जाएगा. That what it means? It means that human intelligence can be created into the computing softwares which we have, or computing computational background which we have. Okay, so quantum will add to it, and it is being touted as quantum AI. Okay, so AGI or ASI will become possible with the new physics. So we need to be cognizant of this fact and focus our energies and see that we are working towards it. And these technologies or new physics becomes the part of our curriculum, our skills, and our education system. From the AI knowledge perspective, if you look at from the symbolic world, we are going towards the more sub-symbolic world, leveraging the algorithms into all our softwares, which is there. So the human, the need for coding will go away, more of it, and more algorithm dependency will come in, which will be self-healing and self-evolving as well. Okay. So what it means, I was talking to a gentleman and a very senior professional in IT industry, and he pointed out that AI, in coming decade, we humans have written 8 billion lines of code. All our CRM, CRPs, websites, internal systems, SCM, all you put together, we have written around 8 billion lines of code. In coming decade, probably these 8 billion lines of code will move on algorithms or AI. Okay, so it will have a huge impact in the way our industry operates, specifically the IT industry, where we are servicing from India. That's the reason we need to start looking at options of developing our own product line, our own platforms, our own applications, which is more AI focused. Okay, every stream of education is going to get impacted with AI. Okay, be it computer science, which is already getting impacted, robotics and all, but human behavior, philosophy, psychology, everything is going to get impacted with AI technologies. It is going to be pervasive. We need to become aware to it. So I was talking about that. We have to accept it. The Moore law is going to get disrupted, and the technological singularity, it is inevitable. By 2030, the prediction is we'll be not driving, we'll not get it. The vehicles, the autonomous vehicles will be driving us around. Right? Probably the new bestseller will be written by AI in between 2040 and on. Okay, and by 2040, we will not even understand who we are talking to. It may be a humanoid or a human being. Will be not. If you are, if you look at Sophia, to YouTube, you can hit Sophia. Humanoid form factors are there, which is leveraging NLP technologies to talk to you. And basically, the Hanson robotics there, what it has brought in on Sophia face, 28 step motors, the smile, the being sarcastic, being sad. So she's not only talking to you like Siri or Cortana or Alexa, but it's also bringing the humor expression on and that. Being sarcastic and being sad and being happy, right? So humanoids are going to be there, more and more prominent. They'll become part of us. Actually, Saudi Arabia went ahead and given a citizenship to Sophia, right? So they will be there all around us. So we need to, and you know how this technology time crunches the timeline, gentlemen. So that is something we need to be more pronounced and more aware of it. Where is the AI technology set? Where is the human parity? On object recognition, by 2016, it was already 96%, close to us. On speech recognition, the error rate is 5.1%, okay, which is actually better than us. We humans make around 5.5% on the speech recognition, the error rate we have. It has gone beyond us. On machine reading comprehension, it was already 88.493% by 2018. We have already 2 years past that, gentlemen, 1921. So you can well imagine where it will be today. Machine translation, 69.9% in 2018. So there are applications which can translate any language to any other language set, right? So you can talk to a gentleman in Japan, though you don't understand, leveraging the machine, the AI. So human parity, it is coming in very fast. It is becoming a part of our world, much more integrated. A lot of other technology focus areas are being developed, and we need to become cognizant to that and start working, like human brain emulation, the whole brain emulation. Emulations are being thought and being experimented to be created, where the neurons, the human, our brain can be sliced, and the neurons and synaptic connections need to be being understood and then being emulated on a software platform. That is the AGI, to achieve AGI perspective or level of AGI. That work is going on. We need to be aware. That means tomorrow there will be emulation. We will be becoming available on the virtual world. Okay. IBM announced Brain in a Box by 2020. And this is, so the world will move from flops to SOPs, synaptic operations per second, because the neuromorphic computing or these chips are coming in. The seed AI, they're being worked. So the whole idea set is that we evolve, right? When we take birth, we have only 30% of the neurons. And over the next 21 years, when we become adult, the additional 70% of neurons develop. That is 10 to the power 38, 78 billion odd neurons which we have. The human brain has got it. So similarly, a seed AI can be developed, and they will neuromorphic chips or hardware accelerators can be added, and it will continue learning it. The differential will be that we become adult and we learn about we become matured in 21 years. When we become adult, probably the AI will become matured enough in 21 months. Okay, BCI is already a possibility. Elon Musk has launched a company known as Neuralink. They are already talking about a chip to be implanted in your brain, which will, so that you can hear the music as you want it, directly coming to your brain. No need of putting an earbuds into your ears going forward. So the world is moving and changing very fast, gentlemen. We need to be aware of it. So how ASI is going to impact us? Let's try to understand it. Okay, that will be very, very interesting, because after this, all this, if you look at the intelligence staircase on this earth, the humans, we are on the top of the intelligence. We operate between 90 to 140 IQ level. Right. Go down below, two staircase. The gorilla or chimpanzees are there. They operate between probably 30 to 40 IQ level. And I'll give you an example. Why don't you go to the nearest zoo, catch hold of a chimpanzee, not the gorilla, they're too powerful, catch hold of a chimpanzee and try to explain trigonometric theorem to him, or probably algebra to him. What he will do to you, I don't know. But you know what the reactions will be, right? You try to do that. Go down to a staircase down below and you will find the chicken is there. And chicken also does have an IQ level, okay, probably 5, 10, 15, but it does have an IQ level. They are instinctive. They bring up their kids, the eggs and all. They know how to work on it. They do have an IQ level. What we do with them? We are eating them day in and day night, right? And in crores actually across the globe. Chicken chili, chicken tandoori, chicken whatnot. We are eating them up. Go down below, a few steps down below, and you have got the insects, and you know what we have done. We have virtually obliterated them from our world. Okay, no mosquitoes, no ants in our households. We have announced a chemical warfare head, Kachap, what not we are doing with them. And we are actually learning from them on the swarm computing, from the bees and ants, how they are behaving, how they collaborate. We are learning from them. So you know how we are treating our own intelligence people on this earth. So if you go on the right hand side of the screen, you will see the biological range of intelligence on this earth. Between 90 to 140 IQ level, we are on the top extreme. So this is the entire. When AGI will come in, it will operate at 5,000 IQ level. The ASI is being touted to operate at 12,500 IQ level. You can well understand any innovation, any strategic thinking, theorems which AI or AGI and ASI will bring on the table, we will be not able to even understand and appreciate that. That's the fear, gentlemen. Okay. So where is the technology at this point of time? The 2.5 million neurons in the deep learning platform, we are equal to a mosquito at this point of time. Okay, very soon probably we'll be crossing a rat brain when we are simulating the AI on our software platforms or our hardware platforms currently, before neuromorphic computing comes in completely. And that will take us to AGI, which is the human level of intelligence, and then it will surpass us. It will be a collective all human brains put together. That will be ASI, which will be reaching us. So what is the AI takeoff? That is imminent, gentlemen. It is an imminent intelligence explosion which is going to happen. And we have got two options. One option is we walk towards extinction, or other is the immortality. We'll become immortals, right? And let's try to understand that. And I believe more on the right hand side, because I believe in human resilience, and that is where we need to start working together on. So AI will be helping us, that will make the world collateral, more collaterals like MR, mixed reality, AR, VR. So you will be not only learning it, books, you will be actually experiencing your history, your technology set, and you know the human brain, how we are formatted. When there is an experience, we don't forget it. We learn much more faster. Okay, so periodic table you will not learning. You will be actually experiencing periodic table on a 3 dimension, and you will remember exactly how the elements interact together. That is the world which is walking in, and there are devices already available. You can go ahead, HoloLens. It is disrupting the education system already. In India, there are some of our partners like Ajna Lens is there. Reliance has announced GeoLens actually, which will, and the technology is little costlier at this point of time, but you know technology, how it becomes cheaper as it progresses. The want to live forever, right? And that is the aging process. So technologies like CRISPR is already there, which is helping us to, in our DNA, which has got around 700 million genomes, we exactly know how to cut out it from our DNA some of the diseases like Wolf syndrome and all, and they are working towards changing your DNA to be free from diabetes, cancer, etc. But you know, ASI is being touted to help human beings through the genomes, many more other proteins which needs to be impacted to stop aging or delay aging, or we call it escape from aging. Google has formed up a company known as Calico, right? They are working towards it. A lot of other foundations and all are working towards it, and they are leveraging AI now. So ASI or AGI will be helping us into moving into it, and that is where probably from humans or from Homo sapiens will become more like Homo Deus. Okay, from Mano to Devta, that journey can be achieved, and that is where AI disruption is going to come in. AI ethics is a big game, big thing. We are worried, and the world is worried about it. The good AI and bad AI, and probably that's not the time here for me to cover on it. But what I'm trying to say, that this is going to become very, very pronounced and very, very important for us human beings in coming years. By the way, the Sanskrit is being touted as the most unambiguous language for AI, and also our Upanishads can help us in modeling good AI. So work is going on, and I believe that is something where us and Government of India as well, they need to focus upon more and more into these aspects and see what we can add or the value addition we can bring on the table from the Indian perspective, and see that we move much more faster in AI. So currently, if you read the book, Kung Fu Lee book, that AI superpowers, US and China, what he is projecting, US will be doing all the research and IP development, and China will be implementing it. Where do we exist? We have to start contemplating on it. Next warfare is not going to be fought by any like nuclear bombs and all. It will be all AI based, and that will be very, very critical. Countries have started understanding the impact of it and see how do we counter it, how do we become part of it. Okay, so from Homo sapiens, which we are already suffering from war, famine, and disease, probably will become Homo Deus with the help of AI, which will be talking about immortality, happiness, and divinity. We will be achieving a divinity too, because with the precision agriculture, AI will be doing everything from sowing the seed to growing it up to ripping it, processing, and even cooking the food and bringing on our table. And autonomous vehicles, kind of AI-based autonomous vehicles, they will be actually making us travel any place to any place, probably at a very fraction of the cost with what we spend today. So we will be moving from Homo sapiens to Homo Deus. That's the journey AI promises, and we need to become part of it. The most important factor from ASI perspective, we need to understand that ASI or the singleton, it's a decisive strategic advantage. And that is what every large corporation or every country who is investing into AI space wants to achieve. Okay, a nuclear bomb was a decisive strategic advantage. And you know what happened? Once people develop it, they put a non-proliferation treaty in place. India took 32 years to have its own nuclear bomb, right? Pokhran, 1974. When they developed ICBMs, IRBMs, and Star Wars, the next big thing, what happened was it was a ban on cryogenic engine. We took 25 years to develop our own technology set. AI, as it is reaching AGI level, already it is being touted. And there has been a suggestion to Trump government actually in US to start putting ban on technologies decimation actually. So we need to become more aware of these facts and see that India as a country is not compromised, or probably it doesn't impose AI as mature, doesn't impose an existential risk to us. We need to understand that, because being it, and it will be also creating a runaway innovation, gentlemen. So AI, when walks into innovation cycle, will be talking about probably 5 technologies, and humans, AI will be talking hundreds of more technologies, and creating it and helping us achieve it. It will be a runaway innovation, and there is no catching up at this point of time. If you look at top 100 AI startups, they are emanating from Northern America. China is catching up very fast. We are not in the industrial map of 4.0, Industrial Revolution 4.0 map. We need to ensure that on AI-FT technologies, we do have startups, we do have our own platform, products, applications, and that is the focus and investment India has to do aggressively. US is putting in more than $3 trillion into AI space. Companies like Google, Amazon, IBM, they've all met hands, right? And they partnership on AI, they are already doing it. So we need to become aware of these facts and see that we are part of this whole revolution. China is doing the similar thing at their end and promoting it. They have brought AI to the third in education system from the third class only, right? I mean the standard third. So they are doing it. If you look from the industry, this artificial narrow intelligence world, every domain is impacted, from being an automotive, manufacturing, consumer, finance. Though, if you look from what perspective they are being impacted, from real-time optimization to radical personalization to process unstructured data set, they are being impacted at this point of time. So you can well imagine that it reaches to the peak, to the AGI level, how much more impact the AI is going to bring in. Okay, 2 things we need to remember, that wherever there is an ROI and there is a data richness, AI will walk in. Okay. So this is the use cases. If you look from these use cases in finance and social sector, the data richness, data availability is there, and there is an impact more than one. AI is going to walk in all aspects of it. And where there is a data richness is available, obviously organizations are looking at more digital transformation and see that data richness is achieved there too. Okay, that means more and more aspects of organizations, be it industry, be it academia or government, AI is going to walk in into our economy and society. What we are looking at we are the next set of industry, or the industry which is what being achieved will be a hyper competitive digital enterprise. So enterprises will become a hyper competitive digital enterprises. So from programming to training, Moore's law to new physics, data lakes to data everywhere. From imperative, it will become declarative. Okay. From scarce memory, memory is going to become an abundance. It is everywhere. A more abundant memory sets will be there. The industry will become from hindsight to foresight. So it will be not a causal. A cause happens and then we write a SOP on top of it to avoid that next time. Actually, it will get predicted. And a lot of industry we are working with, they are looking at those capability to bring a predictive analytics or foresightedness into behavior. Okay, so we can predict a machine failure, and so that the preventive maintenance can be achieved earlier into it. The world from central authority to will become more distributed, and that will be more just and fair world. That is what I believe in. Okay, data burden will become an opportunity. So currently the kind of data we are generating from a billion more IoT devices, from all our other sensors, that is going to become an opportunity for industry and for academia and everybody else. If you don't have an AI strategy, you are going to die in the world that is coming. Okay, I completely believe in it. We need to adopt, we need to understand it and adopt an AI strategy, whatever area, whatever industry, whatever organizations we are working in. From the job perspective, Dr. Sir, I believe you guys are still there. Hello.
Hello, I'm very much there. I'm not able to understand why you're not able to see me, because I've been sitting for your presentation right from the beginning. But I did not want to interrupt you because you're lining up.
Then that's okay, Dr. Sev.
Lining up, and
Right.
I'm literally raring to start sharing them with you. But it's a fabulous input. I'm yet to decide, is it a horror movie or is it a exciting sci-fi movie?
So let me make it more exciting now. Okay. So let's look at from the job perspective, Dr. Sev. Thanks for your feedback. From the perspective, the jobs which we are looking at, the jobs which will need compassion and which will need creativity and strategy, those jobs will be still with the human beings. The jobs which compassion is not needed, okay, and can be optimized, those jobs will be gone, okay. And so look from this perspective, the jobs on the quadrant below on the right hand side will be gone from human beings. The jobs from the optimization and compassion, not like the drivers and all those security guards, drivers, retail people, that jobs will be gone for human beings. Jobs like these will be gone, but jobs like wedding planner, where there is a compassion needed, or an elderly companion will be still left out, or a teacher will be still left out to the human beings. Okay, so this is how the world of jobs will be looking at us. Where a lot of creativity required, humans will be leveraging AI. But as the creativity goes down and compassion not needed, the AI will take over the jobs. Optimization, compassion not needed, those jobs will be completely gone from human beings. Where there is a compassion needed and can be optimized, humans will be leveraging AI in a larger set. But where strategy, creativity and compassion all are needed, humans will be still there, and they will be leveraging AI to an extent, or they will be augmented by AI. So jobs below 60K, they are at risk. Like waiters, cashiers, retail sales, personal care aides, store clerks, they are at risk. But jobs like physicians, surgeons, chief executives, it's definitely something humans will be still continue contributing to it. So what we need to do, we have to ensure that our people, our students, professionals, they become more and more critical thinkers. They know how to push the envelope. So where the humans will be more effective and the jobs will be there, we need to live a more naturally curious life. We have to learn our skill set and learn how to not to be easily overwhelmed, and we have to love math and science. That is very, very critical. Okay. So these are some of the non-tech skills for artificial intelligence world which is walking in. Look at this statement from Putin. Recently he came out and said artificial intelligence is the future, not only for Russia but for all humankind. It comes with colossal opportunities, but also threats that are difficult to predict. Whoever becomes the leader in this sphere will become the ruler of the world. They are very clear. Ruler of the world. That is something we need to take cognizance of on. Okay, AI will be leveraged for that. Okay, so something that is we need to ensure that we are party to this world. There is an emerging new world order, gentlemen. We need to be party to it. Look at the sites which they have. Companies like Amazon, Google, Apple, they are Microsoft, IBM. They have made hands. They have created a site. They call it Partners on AI. They are sharing IPs. They are sharing knowledge. They have adopted a strategy. They call it AI first strategy. Where we are. We need to be party to this kind of a thought process. US pumping in more than $3 trillion. China bringing in $147 billion into AI. China has already taken a lead in publication of AI research papers. Okay, the maximum deal size, if you look at deals here in AI, it is in Northern America which is leading at this point of time. European countries, Russia, they're all focusing their energies on AI, and that is the cognizance we wanted to bring in. What I believe is that India is on the cusp of century's biggest opportunity. We have got all the factors in place for us. More than 3.5 million people in IT industry, which can be retrained, reskilled on the AI EFT technology sets. Okay, we can start leveraging it much more faster. We can move our world more to productize it, more to develop our own applications and platforms, which is very, very critical at this point of time. From every industry perspective, and specifically PSUs has to wake up to this fact and join hands. Okay, that is very, very critical for India at this point. Probably this is an opportunity, century's opportunity for us to become a Vishwaguru. What we are doing. So what we are doing from Vithi Research Foundation, we are helping universities to establish AI innovation hubs, or we call it AI EFT innovation hubs. Put up a high performance computing center, help them in designing and putting up an AR, VR, MR lab, an IoT lab, a neuromorphic computing or VLSI design lab, and also double it up for as an incubation centers for startups. Startups are very, very critical. It not only generates jobs, it also brings technologies and IPs to India, which other universities and academia is very, very poor. Okay, in industry academia collaboration or generating IP, we are all aware of and cognizant of that fact. Something it needs to be changed very quickly and urgently. That is where we are working. We call it hub and spoke model. We are establishing AI innovation hubs into exchanges into tier 1, tier 2 cities, and hubs into academia. We are already partners to more than 15 universities and few of the ITs also at this point of time. And we are working with them, convincing them to move into AI-FT space much more aggressively. These will also work as delivery centers, so we can upgrade the faculty, do the faculty development program, and also mix hand dirty of students through internship and capstone real-time projects of industry through exchanges. We can move it. So we call it a distributed dynamic delivery centers, these hubs. That is very, very critical. This is what the hubs will look like. And we have just signed up an MOU with IIIT Bhagalpur to establish one there too. We have inaugurated Innov with World University of Design, where AI and design thinking innovation hub we are putting in. And that is where we are working with WD Sonipat. These are some of the courses or reskilling perspective we have brought in terms of and training and education, in terms of PBL or project-based, and a CBL to make hand dirty, a domain-focused AI from fintech down to healthcare is very, very critical. People need to understand how domain and the horizontal technologies like AIFT work together. Projects and product development on incubation is very, very, and that is something which we are also intervening in. And the research perspective has to be brought in, and it has to be generated. Obviously, we adopt to the strategy of AI for all. So we are working on multiple domain perspective, different kind of projects at this point of time. Vithi Foundation, from Vithi Research Foundation, we are working on few societal impact, public benefit applications like Project Dudi. So Dudi is a Sanskrit word. It means Kachua. And we are working with IIT Roper and WD to develop a robotic implementation which can identify inorganic waste into our water bodies and can taken out. These will be connected devices. It will move all this. It will have an high resolution camera and a lidar to go on working day and night out and clean our water systems, be it placid waters like lakes and talabs, along with running water in our Namami Gange kind of project and coastal areas, which is quite dirty at this point of killing our flora and fauna into these water bodies. And drinking water, this will also have sensors to report on micropollutants and chemical pollutants in our and the water health, so that a better water map can be developed and a water management, which is one of the United Nations SDG goals, can be done much more better. Drinking water is going to become a biggest problem in coming decade, and that is where we want to impact. So come join us, gentlemen. We are there on LinkedIn as the AI for Humanity group. You can join us, Women of AI. On Facebook, you can be there with us. I'm on Twitter. We have created an AI community hurdle, industry leader roundtable, a group of vice chancellors. That is what we are driving it, and more going into that direction. Thank you.
Thank you for listening. It was really eye-opener presentation of yours. As I told you just a few moments back, I was not able to really evaluate whether I was watching a horror movie or I was watching a science fiction movie. But either way, it gave us a lot of fabulous inputs. Now, if you permit us, we have a couple of questions which have come in from different participants, and we'd like to put them across to you, sir, and take your valuable inputs. Is it all right with you, Professor Kundan?
Thank you. Yeah.
Okay. One of the questions is, the previous speaker, Dr. Snehashis, mentioned that without human interference, the algorithmic systems are bound to make a lot of errors. But whereas your presentation, you spoke at length of how the artificial intelligence is going to completely take over the, I would say, 60 or 70% of the human functions. So are these contradictory or are these supportive? The question, it has come from Ramesh Raut of Manav Rachna University.
So, Dr. Shiv and to Ramesh Rautji, I was not party to, unfortunately, I missed the presentation of Dr. Snehashis Mukhopadhyay. But what I believe what he was referring to, the current world of AI or the narrow intelligence world which we are living in, or the machine learning which we are talking, the algorithms, they need a structured data set or training data set. That is where human intervention is there. And whatever we are training these algorithms, we are also transmitting our human bias also, because the data set itself is biased a lot of time. So we are transmitting that. But once the AI will start moving from ANI to AGI, which is already doing that transition, the unsupervised learning, creating its own insight, it will not need human beings. Okay, like let me give you an example. From AlphaGo to AlphaZero, the Google developed AlphaZero. AlphaZero never played with a human being. It played with AlphaGo to learn it. It's an alien. And when you play with him, you will be not able to win from him. He has learned in 40 days, 3,000 years of human experience of Go and learning with AlphaZero. Google AlphaZero has brought insight. Okay. But it has not leveraged the human data set to learn from. It has played from AlphaGo. So this is how the world is changing pretty fast. Okay. That we need to be cognizant for.
Okay. And the next question is from Mr. Anurag Gangwar, Executive Director, POSOCO. How is artificial intelligence going to help us in our management of HR systems?
See, there are multiple interventions which AI is bringing in. I can give you one example of in HR systems. The first level of interview, some of the IT companies have already implemented AI to take that. And this AI actually talks to you. The idea is that human biasness into the first level of interview, because we humans are biased through states, language, caste, creed, all that we are biased from. So obviously anybody who walks in, we put our bias in front of it, right? But now they are implementing AI, or they have started implementing AI to reduce that biasness. And AI talks to the gentleman. He's doing the first level of interview and ensuring that the resume, whatever resume you have put it in, you walk the talk. Okay, it's only ensuring you walk the talk. That is where AI intervention is. That means the second level of interview, and that is the AI interview, that will be more happening with a human being. The first level will always move to the AI for doing the interview, so that much more better fit for the job can be found out. Okay, by negating the human biasness. But there can be a lot of other implementations of HR which we can think through and identify those use cases in optimization, in doing psychometric testing, and all those things where AI is already making its impact. Thank you.
Okay, the next question is from, who is this? Satish Thakur. Satish Thakur from Power Grid Corporation. Satish Thakur is from the technology department. He's a senior chief engineer, maintenance and operation. He said, we have tried using AI for predicting failures, but it did not work. And how do you think we can improve upon it?
So there are two factors, and that is something because we are also working upon with companies like Tata Power and Integrate and all, and definitely the whole focus there has been on the cable fault analysis, predicting the cable fault analysis, as well as the life analysis of power transformers and grid transformers. That's the focus we are working with them. We understand two aspects which we need to be aware and cognizant. This is not a panacea. This is not a silver bullet. AI at this point of time is not a silver bullet. Everything it cannot do. Okay. Second, it is very, very important. Then whenever you are trying to implement a machine learning, there are few algorithms, around 28 algorithms are given at this point of time. So these algorithms, there is a combinatorial explosion of it. Whatever you are trying to achieve or outcome, you need to validate it, and that is where we walk in. We support in validating those algorithms and see that the outcome accuracy which you are expecting, because if you don't achieve an outcome accuracy probably more than 90%, it will be not so useful for you. So those algorithms need to be understood, and then you have to understand what is the data richness. What is the kind of data you are providing? If you are data rich enough and algorithms are right and validated, obviously you will get a success into whatever you are trying to achieve. And probably we can connect offline. My numbers are there. We can connect offline and see that how do we contribute to your thought process. For Tata Power and Integrate and all, we are working on multiple aspects. We are working with IT Roper on that into some of the solutions, and we can connect offline and probably discuss it.
I have a question from my own side, sir. We are a population of 140 crores, or maybe, as you mentioned, 1.358 billion. Now, in the 4 quadrants that you had shown, there is only one quadrant where human intervention would probably be required, where emotions or intensity of feelings are involved. The rest would be taken over by AI. Now, probably that model would apply to the entire globe. So how is the population going to react in terms of generation of work, generation of resources, generation of adaptability to the new environment?
It is a very pertinent question, Dr. Sev. What I believe is that AI, as it is maturing towards AGI and ASI, right, it is going to impose an existential risk. It is going to create a lot of pain for India. I'll give you an example. I was reading a White House report on autonomous vehicles specifically, and they were talking about that as autonomous vehicles comes in, from trucks to taxis to down below on a private cars and all, they become more autonomous. 2.5 million jobs in US will be at stake. So they were talking about retooling and reskilling them. Now let's translate the same companies they are working, like Google and other companies, Uber and all, who are working on autonomous vehicles. These vehicles will also get translated to India, because all those companies
Correct.
Daimler, General Motors, they're all in India too, right?
Correct.
So those cars and autonomous vehicles will come. Whatever we say we don't want it, 1.6 crore drivers at our end will be at stake as it
Absolutely.
progresses.
Absolutely.
Absolutely. And that is, and they 2.5 million drivers in US, if they are at stake, they are talking reskilling and retooling them. What we are going to do. Some of these drivers even not third standard pass, right? They have not done their primary education.
Absolutely.
And how we are going to handle it. So there is a big pain point there, and that is something we need to understand. It is very, very critical and urgent at this point of time. And I always evangelize this. I work with government, I work with academia and universities, and trying to push this thought process to them that is very, very critical at this point of time for us. Okay, and this is something. Let's take another example like precision agriculture. Precision agriculture is talking about that AI will step in sowing the seed, growing it up with the weather data sets and everything. It knows exactly, precisely how much water, fertilizer, nutrients have to be provided. So it will grow it, it will process it, and it will cook the food and bring it on our table. What will happen to our agriculture? I mean, our kisans, right? You know the education levels which they do have. What kind of retooling and reskilling we are thinking
Right.
about it? Okay, we need to prepare for the world which is coming in. So that's the reason my narrative is always there, that it imposes an existential risk for India. We need to become aware of it and start working towards it. It's an opportunity, but it's had got a downside as well. Thank you.
Right. Thank you very much, Dr. Kundan Lal and Professor Kundan Lal. I'm so sorry, and it's been a real excellent eye opener. And as I was saying to the previous speaker, also, the entire recording is going to be submitted without any editing to the Department of Public Enterprise and to the PMO. And we do hope they will we have been assured they will be taking up the cues from the inputs that you give us and you gave all the participants, and many of which would be used and implemented in the days to come. And we are looking forward for a new India. This particular program is totally directed towards the new India. We would be doing one more of these sessions maybe in a month or 2 months, depends upon the coronavirus's presence or existence or non-existence. But we will be doing another program. But in the meantime, tomorrow we are meeting between 3 and 5 o'clock to felicitate you and to welcome you. And the felicitation would probably be done either by Dr. C.P. Thakur or Professor Dr. Priyaranjan Trivedi, Vice Chancellor of International Confederation of University. Dr. Markandeya Rai of United Nations would also be there. So if you could make it to the venue, sir, we would be very grateful, and we would love to have you with us and share your experience of today, tomorrow also, some of the insights, and maybe meet the dignitaries who come on board on that occasion. It's between 3 o'clock to 5 o'clock tomorrow. Uh, I would send you the
Thank
details, and they would
Yeah, please do share it. Please do share it.
I'll ask the office to send you all the details, and we'll coordinate with you, sir, for your suitability. But in the meantime, thank you very much once again. It was a wonderful, eye-opening experience and session, and it's brought in so much of questions within me that, time permitting, I would have probably bogged you down with more. But people are scheduled to go for lunch, so I cannot keep them back from their lunchtime. So we hope to meet you tomorrow again, and probably physically. Thanks a lot, sir.
Done, sir.
Thank you very much.
Done, sir. Thank you. Take care.
Thanks.